C gives us a series from n equals 1 to infinity of e to the 1 over n power over n squared. And so to find the convergence or divergence of this series, the ratio test would not have worked. It would have been a very painstaking calculation if you look e to the 1 over n to the n squared. The limit calculation probably would have been indeterminate. The series is also not geometric, so we can't use that test. And direct comparison and limit comparison wouldn't have worked because there's no series we really know that we can compare with this series right here in terms of n. And the divergence test also wouldn't have helped just by looking at it, because the limit as n goes to infinity of this e to the 1 over n squared would just be e to the 0 over infinity squared, which would be 1 over infinity, which would be 0. And 0 is inconclusive for the divergence or eyeball test. So that's the only viable test left to do was the integral test. And so I made it this integral. Limit is n goes to infinity from 1 to n of e to the 1 over x squared dx to compare this series to. I made u equal to 1 over x for u substitution, because I knew that the derivative of 1 over x is negative x to the negative 2, which would eventually cancel out. This was with this x squared here. And so simplified this down to find that dx equals negative du x squared. And u of 1 is 1, and u of infinity is 0 for this limit as n goes to infinity. So we can rewrite this integral as the integral from 1 to 0 in terms of u of e to the u over x squared minus negative du x squared. So these x squareds cancel like I predicted. So we're left with integral from 1 to 0 of negative e to the u du. And the antiderivative of negative e to the u is just negative e to the u. And that from 1 to 0 equals negative e to the 0 minus negative e to the 1. Negative e to the 0 is negative 1, and negative e is negative e, but then subtract that and it becomes a positive, so the answer is just e minus 1. Not the answer, sorry, this integral converges to e minus 1. So by the integral test, whatever the integral does, the series does as well. And so this integral converges to e minus 1. So therefore, this series that we're comparing it to must converge as well.